wavelength of the sound. So what is the wavelength of a sound wave with a frequency 20 Hz traveling a speed of 343 meters per second? So first of all, we already know the formula for the speed of the sound of the wave is equal with the product of the frequency of the wave time of the wavelength. Let's say wavelength, usually we write with a lambda. Okay, f represents the frequency and v speed of the wavelength. So now we already have here what we have here. We already have here the frequency, which is at 20 Hz. So let's write here frequency is equal to the 20 Hz. And the other thing what we have here in this word problem, we have the speed of the wave. So the speed is traveling at the wave is traveling at 343 meters per second. So, and let's say v here. Let me write here v is equal to 343 meters per second. 343 meters per second. But since we have to find the lambda here, so we are going everything to divide by the frequency f, whole equation. If we divide everything by f, we have a v divided by f, so the speed of the wave is divided by the frequency, is equal to the f times lambda divided by everything by the frequency f. But as we see here, we cannot divide this, we can simplify f by f, and finally lambda is equal to the v. So lambda is equal to the v divided by f. And now we can plug in everything in. So v is already 343 divided by 10, 343 meter per second. Okay, divided by the frequency is 20 Hz. But the hertz we already know, instead of the 20 Hz, we can write 20 times 1 over second here. And what do we get here? 333 divided. So second with a second we can simplify, because 1 Hz is equal to 1 over second per units. So in second with a second we can simplify, and what it remains here remains, just let me go quickly here. Here remains 343 divided by 20. So we can find, which is 17.15. So lambda is equal with 17.15 meter. So the wavelength of the sound is 17.15 meter.